This is an example of using the product rule, the power rule, and the quotient rule of logarithms, though it doesn't say those words anywhere in this. It says, evaluate the expressions and write each answer as a single logarithm. Now, when it says single logarithm, what it implies is it's just log of something, right? Not log of this plus log of that, and so on. And in getting these things down to a single logarithm, we're going to use those rules that I mentioned. So let me first show what I mean by writing this in this the most basic form that I can think of using substitutions. So if I say 2x using the x that's shown above, what that'll be is 2 times log base b of 8. Okay, that's 2x. And if I say plus y, what I mean is plus log base b of 5. Okay, so this is 2x plus y, and don't let anyone tell you it's not 2x plus y. However, it is not simplified into a single logarithm, and that's what this problem wants for the answer. So we're not wrong, we're not right yet. So we have to combine these things and make it a single logarithm. And the first thing I'm going to do is address this right here, that 2 that's out front. I'm going to use the power rule to rearrange this logarithm to log base b of 8 squared. See how the 2 went up into the exponent? If that had been a 3 in front of the logarithm, it would become 8 cubed. If it had been a 4 in front of the logarithm, it would have been 8 to the 4th. And let's just keep this one the same for now. And I want to move these into a single logarithm as my next step. That will use the product rule. So I'm going to write a single log base b. And now look what I'm doing. This is 8 squared times 5. Okay, that was the product rule that allows the arguments to multiply together in exchange for making a single logarithm out of it. Now, this isn't quite simplified. I could say, what is 8 squared? Okay, so, go away. 8 squared is 64. So 8 squared times 5, I don't know, 320-ish. Okay, so this is going to be equal to log base b of 320 in this example. That would be my answer. See, that's a single logarithm. It's as simplified as I can make it. Let's try this other one. So if I say x minus y, what I mean literally is log base b of 8 minus log base b of 5. That's x minus y. But I want it simplified. I want it as a single logarithm. So sometimes in class I talk about this as forming a megalog. It's one logarithm to rule them all, right? So we just say log, and I'm going to put a fraction symbol in here. Every log that was positive goes on top. Now that's just the number 8. There were no other positive logs with an argument. But every negative log goes on bottom. So that's going to be the 5. So this is log base b of 8 over 5. You can see that minus sign acting kind of like a division when we talk about the arguments. You may notice that there's a connection between the way logarithms behave and the way exponentials behave, right? If you remember how exponentials multiply together, when you multiply two exponents, the exponents add instead of multiplying. And when you divide two exponentials, the exponents subtract. There's a very good reason why logs and exponents are similar in terms of their behaviors, but we'll have to get into that more in a separate video.